All right, let's dive into one of the biggest, most classic debates in the Java world, abstract classes versus interfaces. I mean, this is something every single developer has to get their head around. And trust me, it's way more than just some question you memorize for an exam. This is a core design choice that really shapes how good and how flexible your code can be.
So picture this, right? You're in a tech interview. It's going great. You're feeling confident. And then the interviewer leans forward and asks, so tell me the difference between an abstract class and an interface. And your mind just goes blank. It's that classic make or break question. Well, don't worry. We are going to fix that right now.
Okay, first up, let's talk about the abstract class. The best way to think about this is like a flexible blueprint for a house. It's got some of the walls built, maybe the foundation is poured, but other parts are left intentionally blank for you to finish. Now, here's the #1 rule you have to remember. You cannot create an object directly from an abstract class. You can't just say new shape. Why? Well, because it's not a finished thing. It's just a template, a starting point for other, more specific classes. And this is where the real magic is. An abstract class can have a mix of methods. You can have abstract methods, which are basically just method names, no code inside. They're like a to-do list. But you can also have concrete methods, which are fully coded and ready to go. Any class that inherits from it, well, it gets all that finished code for free. But it must complete that to-do list and write the code for all the abstract methods. This analogy just nails it. Think about a company's general employee class. It might have a fully written, concrete method called submit timesheet, because everyone does that the exact same way. But it could also have an abstract method called perform daily tasks. Why? Because what a software engineer does every day is totally different from what a salesperson does. The abstract class says, hey, you must have this function, but it leaves it up to the specific employee types to define how they do it. Okay, so now let's switch gears and look at the other contender in this showdown, the interface. If an abstract class is that flexible blueprint, an interface is a super strict 100% pure contract, no wiggle room. An interface is all about defining a capability. It's a promise. When a class says it implements an interface, it is making a solemn vow. It's saying, I guarantee that I can do everything listed in this contract. The interface itself, it provides zero details on how to do it. It's just a list of rules. And this is the absolute game changer for interfaces. In Java, a class can only inherit from one other class. That's a big limitation. But a class can implement as many interfaces as it wants. This is how Java solves the famous multiple inheritance problem. Your class can suddenly gain abilities from all these different unrelated contracts. It's incredibly powerful. This is just a perfect way to think about it. Imagine an interface called Pilot. It would list the required skills, right? Take off, fly, land. The interface doesn't care if the class implementing it is a human pilot or a drone AI. As long as both of them can fulfill that contract and perform those actions, the system can treat them both simply as a pilot. Okay, we've met the two contenders. Now it's time for the main event. Let's put them side by side and really break down the differences so you can nail that interview question every single time. Before we even get into the weeds, let's just start with the core philosophy. It boils down to this. You use an abstract class when you want to share common code and data among closely related classes. And you use an interface when you want to define a common behavior or capability that even completely unrelated classes can share. It's all about sharing code versus sharing a capability. So this table really lays it all out. You see the keyword difference, extends versus implements. Look at the methods. Abstract classes have that mix of abstract and concrete, while interfaces are all about the abstract promise. Now, modern Java has added default methods to interfaces, but the core idea is still pure abstraction. And of course, the big one at the bottom, inheritance. You can only extend one class, but you can implement many, many interfaces. Look, theory is one thing, but let's make this real. Let's see how these two concepts work together by designing a simple payment gateway. This is where it all clicks. So our goal is to handle payments from credit cards, UPI, you name it. We're going to start with an abstract class, payment processor. Why? Because every single payment type is going to need some shared logic, like logging the transaction. So we can write that log transaction method once, right there in the abstract class. But actually processing the payment? Well, that's totally different for a credit card versus UPI. So we make process payment an abstract method,
forcing each specific payment type to figure that out on its own. Ah, but then your boss comes over and says, we need to handle refunds. But here's the catch. Not all payment types are refundable. We can't just slap a refund method into our abstract payment processor, because then we'd be forcing UPI payments to have a refund method, which doesn't make any sense. So what do we do? And this is where the interface saves the day. We create a new, simple interface called Refundable. All it does is define one method, initiate refund. It's a simple contract. Now, our credit card processor class can still extend payment processor, but it can also implement Refundable. We've just bolted on a new capability to only the classes that need it without messing up our whole design. How clean is that? So after all of that, what's the one thing you need to walk away with? How do you make this decision in your own code day in and day out? Well, it all comes down to a super simple rule of thumb. Here it is, the key takeaway. You use an abstract class when you have an is-our relationship. A credit card processor is a type of payment processor. It's a fundamental identity. You use an interface when you have a has-I capability. Our credit card processor has the ability to be refunded. See the difference? One defines what something is, the other defines what something can do. And that's really the final test, isn't it? Take this is-a versus has-a idea and think back to the last project you worked on, the last time you had to make this choice. It's not just about what works, it's about what makes sense and what's going to be easiest to change in the future. So, did you choose the right tool for the job? Something to think about.